A jockey pump, based on the National Electrical Code, is not defined as an emergency system, nor is it defined as a legally required standby system. Instead, a jockey pump falls under the category of a life safety system. As such, it should be connected to an essential electrical system. This requirement is explicitly detailed in Article 700 of the National Electrical Code. To elaborate, emergency systems, legally required standby systems, and essential electrical systems each serve distinct purposes and have specific requirements outlined in NEC. Emergency systems are typically intended to provide power to critical loads during a utility power outage, ensuring the safety of building occupants and the continuation of essential operations. Legally required standby systems are required by law to provide power to specific loads, such as fire pumps or elevators, ensuring their continued operation during a power outage. Essential electrical systems, on the other hand, encompass a broader range of systems that are deemed essential for the safety and operation of a building, including life safety systems. The NEC defines a life safety system as a system that is designed to protect the life and safety of building occupants, such as fire alarm systems, emergency lighting, and smoke control systems. Since a jockey pump plays a crucial role in maintaining water pressure for fire suppression systems, it is considered a life safety system and must be connected to an essential electrical system. Article 700 of the NEC provides detailed requirements for essential electrical systems, including the types of loads that must be connected to the system, the required capacity of the system, and the requirements for the transfer switch that automatically transfers power to the essential electrical system during a power outage. When connecting a jockey pump to an essential electrical system, it is crucial to comply with all applicable requirements of Article 700. This includes ensuring that the essential electrical system has sufficient capacity to supply the jockey pump, that the transfer switch is properly sized and installed, and that the jockey pump is properly wired and grounded. It is also important to consult with a qualified electrical engineer or contractor to ensure that the installation complies with all applicable codes and standards. Failure to comply with these requirements could result in serious consequences, including the failure of the jockey pump to operate during a fire, which could jeopardize the safety of building occupants. Furthermore, the connection of a jockey pump to an emergency power system or a legally required standby system rather than an essential electrical system may not meet the requirements of the NEC and could result in code violations. The reason for classifying a jockey pump as a life safety system connected to an essential electrical system stems from its critical role in fire protection. A fire suppression system relies on adequate water pressure to effectively extinguish a fire. The jockey pump is designed to maintain this pressure within the fire suppression system piping. Without a functioning jockey pump, the fire suppression system may not operate as intended, potentially leading to catastrophic consequences. Therefore, ensuring the reliable operation of the jockey pump during a power outage is paramount for life safety. The NEC classification of the jockey pump reflects this importance. In summary, the NEC specifically designates the jockey pump as a life safety system, mandating its connection to an essential electrical system as detailed in Article 700. This classification ensures the reliable operation of the fire suppression system, safeguarding building occupants in the event of a fire. Remember that adherence to the NEC is crucial for ensuring the safety and functionality of electrical systems, particularly those related to life safety. Always consult with qualified professionals and refer to the latest edition of the NEC for specific requirements and guidance. To further clarify the requirements for essential electrical systems, Article 700 covers various aspects of design, installation, and maintenance. Firstly, the scope of Article 700 delineates the types of occupancies and systems that necessitate an essential electrical system. These typically include hospitals, emergency treatment facilities, fire stations, and other critical infrastructure where the interruption of electrical power could endanger life safety. Secondly, the types of loads that must be connected to an essential electrical system are specified. These loads generally encompass life safety loads, critical equipment loads, and legally required standby loads. Life safety loads include systems such as emergency lighting, fire alarm systems, and smoke control systems. Critical equipment loads refer to equipment necessary for the continued operation of a facility, such as medical equipment in hospitals or data processing equipment in data centers. Legally required standby loads are those mandated by law or other regulatory agencies to be supplied with standby power, such as fire pumps and elevators. Thirdly, the capacity of the essential electrical system must be sufficient to supply all connected loads simultaneously. This requires a careful assessment of the power requirements of each load and the selection of an appropriate generator or other alternate power source. The NEC provides guidance on calculating the required capacity, taking into account factors such as the diversity of loads and the expected load profile. Fourthly, the transfer switch is a critical component of the essential electrical system. It automatically transfers power from the normal power source to the alternate power source during a power outage. The transfer switch must be properly sized and rated for the connected loads, and it must be designed to operate reliably under all conditions. Fifthly, the wiring and grounding of the essential electrical system must comply with all applicable requirements of the NEC. This includes the use of appropriately sized conductors, proper overcurrent protection, and effective grounding to minimize the risk of electrical shock and fire hazards. Sixthly, the essential electrical system must be regularly inspected and maintained to ensure its continued reliability. This includes testing the generator or other alternate power source, inspecting the transfer switch, and verifying the functionality of all connected loads. The NEC provides guidelines for inspection and maintenance, including recommended intervals and procedures. It is important to note that the requirements for essential electrical systems can vary depending on the specific occupancy and application. Therefore, it is essential to consult with a qualified electrical engineer or contractor to ensure that the design, installation, and maintenance of the essential electrical system comply with all applicable codes and standards. Furthermore, local jurisdictions may have additional requirements that must be met. Therefore, it is important to check with the local electrical inspector to ensure compliance with all applicable local codes and regulations. In addition to Article 700, other articles of the NEC may also be relevant to the design and installation of essential electrical systems. For example, Article 701 covers legally required standby systems, and Article 702 covers optional standby systems. These articles provide additional guidance on the types of loads that may be connected to these systems, the required capacity of the systems, and the requirements for the transfer switch. Moreover, Article 705 covers interconnected electric power production sources such as solar photovoltaic systems and wind turbines. If an essential electrical system includes an interconnected electric power production source, it must comply with the requirements of Article 705, as well as the requirements of Article 700. In conclusion, the NEC provides comprehensive requirements for essential electrical systems, including the types of loads that must be connected to the system, the required capacity of the system, and the requirements for the transfer switch. Compliance with these requirements is essential to ensure the safety and reliability of essential electrical systems, which play a critical role in protecting life safety and ensuring the continued operation of essential facilities. Always consult with qualified professionals and refer to the latest edition of the NEC for specific requirements and guidance. The intent of the NEC is to provide a minimum standard for electrical safety. It is not intended to be a design manual, and it does not cover all possible scenarios. Therefore, it is important to use good engineering judgment and to consult with qualified professionals to ensure that the electrical system is safe and reliable for its intended application. Furthermore, the NEC is constantly evolving to keep pace with new technologies and changing safety requirements. Therefore, it is important to stay up to date on the latest edition of the NEC and to be aware of any changes that may affect the design, installation, and maintenance of electrical systems. The National Fire Protection Association, or NFPA, publishes the NEC, and it is updated every 3 years. The latest edition of the NEC is available for purchase from the NFPA website, and it is also available for review at many libraries and electrical supply houses. In addition to the NEC, there are other codes and standards that may be relevant to the design and installation of electrical systems. These include the National Electrical Safety Code, or NEC, which covers electrical safety requirements for outside electrical installations such as power lines and substations, and the International Building Code, or IC, which covers building code requirements for all types of buildings, including electrical systems. It is important to be aware of all applicable codes and standards and to ensure that the electrical system complies with all requirements. Compliance with these codes and standards is essential to ensure the safety and reliability of electrical systems and to protect life and property from electrical hazards. In practical application, determining the appropriate power source for a jockey pump involves several steps. Firstly, review the project specifications and local codes to identify any specific requirements for the jockey pump power supply. Secondly, consult with the fire protection engineer to understand the criticality of the jockey pump in the overall fire suppression system design. Thirdly, assess the existing electrical infrastructure to determine the availability of suitable power sources. Fourthly, select an essential electrical system that meets the requirements of Article 700 of the NEC. Fifthly, ensure that the essential electrical system has sufficient capacity to supply the jockey pump and all other connected loads. Sixthly, install a properly sized and rated transfer switch to automatically transfer power to the jockey pump during a power outage. Seventhly, wire and ground the jockey pump in accordance with all applicable requirements of the NEC. Eighthly, test the jockey pump and the essential electrical system to verify their proper operation. Ninthly, document all aspects of the installation, including the selection of the essential electrical system, the sizing of the transfer switch, and the wiring and grounding of the jockey pump. Tenthly, maintain the jockey pump and the essential electrical system in accordance with the manufacturer's recommendations and the requirements of the NEC. By following these steps, you can ensure that the jockey pump is properly powered and that the fire suppression system will operate reliably in the event of a fire. Remember that safety is always the top priority when working with electrical systems. Always follow safe work practices and consult with qualified professionals if you have any questions or concerns. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Use properly insulated tools. To energize electrical circuits before working on them. Test electrical circuits to verify that they are de-energized. Lock out and tag out electrical circuits to prevent them from being accidentally energized. Follow all applicable safety regulations and procedures. By following these safety precautions, you can minimize the risk of electrical shock and other electrical hazards. In addition to safety, it is also important to consider the reliability of the electrical system. The electrical system should be designed and installed to provide reliable power to the jockey pump and other essential loads. This includes selecting high-quality components, using proper wiring and grounding techniques, and providing adequate overcurrent protection. The electrical system should also be regularly inspected and maintained to ensure its continued reliability. This includes testing the generator or other alternate power source, inspecting the transfer switch, and verifying the functionality of all connected loads. By ensuring the reliability of the electrical system, you can help to prevent power outages and ensure that the jockey pump and other essential loads will continue to operate during an emergency. Furthermore, consider the maintainability of the electrical system. The electrical system should be designed and installed to be easily accessible for maintenance and repairs. This includes providing adequate clearance around electrical equipment, using properly labeled components, and providing clear and concise documentation. The electrical system should also be regularly inspected and maintained to identify and correct any potential problems before they lead to a failure. By ensuring the maintainability of the electrical system, you can help to reduce downtime and ensure that the jockey pump and other essential loads will be available when they are needed. In addition to the technical aspects of selecting and installing an essential electrical system for a jockey pump, it is also important to consider the cost implications. The cost of an essential electrical system can vary depending on the size and complexity of the system. It is important to obtain competitive bids from qualified electrical contractors and to carefully evaluate the costs and benefits of different options. The cost of an essential electrical system should be considered as part of the overall project budget, and it should be weighed against the potential costs of a fire or other emergency. By carefully considering the cost implications of an essential electrical system, you can make an informed decision that is both cost-effective and safe. In summary, selecting and installing an essential electrical system for a jockey pump is a complex task that requires careful consideration of safety, reliability, maintainability, and cost. By following the guidelines outlined in the NEC and by consulting with qualified professionals, you can ensure that the jockey pump is properly powered and that the fire suppression system will operate reliably in the event of a fire. The goal is to ensure the safety of building occupants and the protection of property. Remember to always prioritize safety and to follow all applicable codes and standards. The NEC is a valuable resource for electrical safety, and it should be consulted whenever working with electrical systems.